Okay, today's lesson is factoring quadratics. Sorry, this is again factoring quadratics. And so what exactly is this topic? Well, let's take a parabola. Y equals x squared plus 4x minus 21. Okay, so, and we're going to come back to this at the end, but we can sketch this parabola, right? We can sketch this. So we know that it's a parabola. We know it's a smile. And we know that A is 1, B is 4, and C is negative 21. So we know the axis of symmetry is negative B over 2A, so it's negative 2. And the turning point, plug it back into the original equation, negative 2 squared plus 4 times negative 2 minus 21, 4 minus 8 minus 21, that is negative 25. Okay, well, let's start to sketch this. So we have, our parabola, our axis right here, and we know, this is x, this is y. We know that it's a parabola, it's a smile. We know the axis of symmetry is x equals negative 2. So it kind of looks like this. X equals negative 2. And we know the turning point is at negative 25. We also know that the y-intercept is negative 21. And so we kind of, negative 21. And so we kind of know, but we can draw the parabola. We can, it's a smile. So it looks like this, and it looks like that. So we have all this information. The axis of symmetry, the turning point. We know the y-intercept. But one thing we spoke about was exactly what are these points? These are known as the x-intercepts. X-intercept. So the question is, how do we find those coordinates? Well, what are those coordinates? Well, you can say, Mr. Adler, I don't know the x value, but I do know the y coordinate is 0. Same thing here. I don't know what the x coordinate is, but I do know the y coordinate is 0. So the idea is we want to solve. So to find the x coordinates, or the x-intercepts, we need to solve, y equals 0, or the equation x plus 4x minus 21 equals 0. So how are we going to figure that out? Can you see that? Yeah. The question is, how are we going to do this? Well, so what we're going to do is we're going to talk about factoring quadratics. What we're going to talk about today is factoring. We're going to factor. Okay, so what's going on here? Now, in a previous class, you learned that when you multiply two binomials together, you got a quadratic. So for example, if I take, x plus 5 times x minus 7, you learned last year to do the FOIL method. So for example, x times x times negative 7, 5 times x, 5 times negative 7. And so you got x squared minus 7x plus 5x minus 35. Another technique you could have used was what I call the box method. So, you put the first binomial on top, make a box, so it's x plus 5, and then you put the other binomial along the side, x minus 7. And so like an Excel spreadsheet, row to column, x squared, row to column, 5x, row to column, negative 7x, row to column, negative 35. You put all the terms, the same thing, you have them all here, And then we can simplify this. So we have x squared minus 2x minus 35. Let's try another one together. How about we multiply x plus 2 times x plus 5. So let's try that together. How about you try it on your own? Okay, I'm back. So we know it's x squared plus 5x plus 2x plus 10. Once again, I can do the box method. X plus 2 on the top, x plus 5 on the bottom, on the side, x squared, 2x, 5x, 10. Write all the terms out, and we have x squared plus 7x plus 10. Well, shall we do another one? Yeah, let's do another one. How about x minus 8, x minus 7? So let's try another one. X times, try it on your own. I'm just going to do it. Final answer, x squared minus 15x plus 56. Now, the idea here is, if I can take two binomials and multiply them together to get, or two linears, and when I multiply them together, I get a quadratic, then there's no reason why I can't take a quadratic and factor it into two linears or two binomials. So once again, we want to do the breakdown. Now, and so that's the idea. The idea is if x plus 5 times x minus 7 gives us x squared, this is the FOIL method, right? Then there's no reason why I can't do factoring. Right? Same idea here. If I can take x plus 2 and turn that into a trinomial, then there's no reason why I can't break it up. Right? Okay, so, and before we start, I want to point out a couple of interesting things about this. Because, so for example, what is, negative 7 plus 5 is 2, but what's negative 7 times 5? That gives me a negative 35. Not a coincidence. Where did the 7 come from? You say, oh, that's 5 plus 2. Where did the 10 come from? 5 times 2. Not a coincidence. What about that 15? Oh, well, that was negative 7 plus negative 8. But where did the positive 56 come from? Oh, negative 7 times negative 8. Not a coincidence. So, we want to look at this quadratic again. But I'm going to start with positive numbers, but let's see how we can do this. So I'm going to teach you how to factor quadratics. Okay. Okay. So we are writing let's start with something basic. How about x squared plus 9x plus 20? Nice. Excellent. Okay. Nice. Step 1, write the parentheses down. If I tell you to factor a quadratic, you know they get to the parentheses. Step 2, so step 1, the parentheses. Step 2, put in the x's. Where did x squared come from? Where did x squared come from in all of these examples? It came from the x and the x. So put your x's in. Step 3, circle the constant. Circle the constant. Right? And then 4. Draw 3 column table and put the constant on top. Put its constant on top. So you're going to draw a 3-column table, and you're going to put that positive 20 on top. Next, I want you to think about every pairs whose product is 20. So I want you to find all the factor pairs. Let's see, what are the factor pairs of 20? Well, I know 1 times 20. I know 2 times 10. I know 4 times 5, and I think that's it. There's nothing else. Perfect. That's 5. In the last column, write the sum. The sum is a fancy word for adding things together, and we'll add them up. Find the sum, and then look for a match. A match with B. What am I talking about, B? B? B. So let's try to find a match. What is 1 plus 20? 21. Do I have a match? No. What is 2 plus 10? 12. Do I have a match? No. 4 plus 5? That's 9. I have a match. Take your 4 and your 5, and you just factor a quadratic. Let's try another one. Let's try another one. We'll leave the rules up here. The next quadratic is, let's see what I have in my notes, x squared plus 10x plus 16. Okay, I'm telling you, you can factor this. Therefore, get your parentheses down, put your x's in. Okay, let's make a table. I circle the constants and put that on top of my table. Okay, what are all the factor pairs of 16? Well, there's 1 and 16. What do you think? 2 and 8. Anything else? Yeah, there's one more, 4 and 4. Okay, now, I said what goes in the last column? The sum. And we're going to look for a match. Oh, yeah. So, 1 plus 16 is 17. Is that a match? No. What about 2 plus 8? 10. Nice. I have a match. You don't need to do any more. Because the 2 and 8 matches with a 10, x plus 2, x plus 8. Excellent. Next problem. Let's see. Okay. X squared plus 13x plus 40. Okay. Well, you can use this method again, but some kids like to speed up the pace. They say, you know what, Mr. Rather, I know that this will break down into 2 binomials. I know that the first terms are x's. I'm just going to make a smaller chart on the side. I'm just going to make a chart like this. And I'm going to run through the factor pairs of 40. 140? No. How about a 220? No. How about, does 3 go into 40? No. 4, 10? 4 plus 10? No, that's not 13. What's next? 5, 8. What's 5 plus 8? 13. Nice. So, x plus 5, x plus 8. Okay. Now, let's introduce some negative numbers. Actually, let's go back to the original problem. Let's go back to the original problem. Let me move my screen over, sorry. Let's see, the original problem was x squared plus 4x minus 21. How are we going to break that down? Now, so the rules were, write the parentheses, put in the x's, and then circle the constant. So the question is, how do I break out my 21? Now, let's do the long way. We have my 3-column chart. I have my negative 21. Let's go through all the factor pairs of 21. Now, from starter, I would say, yeah, write the factor pair. So you might say 1 and negative 21, but you would say, oh, wait a minute, negative 1 and positive 21 also work. Okay, what else? Well, there's 3 and negative 7, and negative 3 and positive 7. And so you'd go through this. 1 minus 21, negative 20. No. Negative 1 plus 21, positive 20? No. How about 3 and negative 7? Negative 4? No. Negative 3 and positive 7? Yes, that's my match. Once again, my match is with positive 4. So, x minus 3, x positive 7. Now, you might say, Mr. Allen, do we need to go through all of this? Like, all the factor pairs and the positives and negatives? Not really. What I'm going to ask you to do is kind of like run numbers slightly through your head, if you have to do this without a calculator. So, let's take another example. How about x squared minus 3x minus 10? Okay, sorry. So you look at this. I'm telling you, you can factor it. I'm telling you, you can factor it. You have the parentheses ready to go. You have the x's here. And you're looking at this, and you say, you know what? I can break 10 into 1 and 10, but that's not getting me to 3. The 1-10 combination is not going to negative 3. But 10 minus 1 or 1 minus, that's not getting you to 3. But you look at 10 and you say, oh, it's 5 times 2, a light bulb goes off. You're like, wait a minute, that's getting me to 3 or negative 3. So you know what? In the table, just write, for negative 3, just write 5 and negative 2 or negative 5 and positive 2. You know one of those is getting you to 3, but like I say it over and over again, negatives will get you. So just say, okay, you know what? Either 5 and negative 2 or negative 5 and positive 2. Well, 5 minus 2 is positive 3. No. Negative 5 plus positive 2, negative 3, that's the match I want. X minus 5, x plus 2. Let's try some more. Let's try some more. And then I will give you a lot of homework to do. Let's see, next problem. X squared minus 3x minus 28. There's a lot of negatives, but we're fine. And some of you are saying, oh, you know what? I know how to break down 28 to get to my 3. Let's throw it down. Okay, I'm telling you, you can factor it. What's the first thing? Parentheses. How do we get the x squared? X and x. How do you want to break down the 28? The 128 combination? That's not getting me to 3. So 128, no. How about 214? That's not getting me to 3. Let's see. 1, 2, 3, 4, 7? Yeah. Yes. The 4, 7. So maybe I'm going to write 4 and negative 7 and negative 4, positive 7. One of those pairs is getting me to negative 3. I see it. I can see it. I'm just really not sure which one. Okay, write them down. 4 minus 3, negative 3. You have your match. X plus 4, x minus 7. Write these down. I know some kids are like, I can do it in my head. Get it down on your paper. Let's try another one. Try these on your own. X squared plus 7x minus 44. X squared minus 9x plus 8. And the challenge is x squared minus 13x minus 48. So pause the video. Pause the video and let's see what you can do. Okay, we're back. Well, let's see, 44, I have my parentheses, my x's. Let's see, 144, that's not getting me to 7. 2 and 22, that's not getting me to 7. 4 and 11, yeah. Let's see, 4 and negative 11, negative 4 and positive 11. Well, 4 minus 11 is negative 7. No, that's not the match. But negative 4 and positive 11, that's my match. X minus 4, x plus 11. Sorry. This one looks a little weird. It looks straightforward. The numbers are clear, but, you know, they look weird. I mean, they look connected. So, once again, you have your parentheses, you have your x's, 8. Well, I know the 8-1 combination, that's getting me to 9. That's it. Because 4 and 2, no. 8, I'm looking at it, I'm like, wait a minute. But how do it's negative. But then I remember from 4th or 5th grade, although a positive times a positive is positive, a negative times a negative is also positive. That's my match. 8 plus 1, 9? No. Negative 8 plus negative 1, negative 9. That's my match. X minus 8, x minus 1. Last example. Well, we don't teach you the 16 times table. It turns out, and figure this out on your own, it's x. Yes, it's x minus 16, x plus 3. How would you figure this out? Some days I have to go through these. 1 and 48, 2 and 24. Let's see. I don't know about 3. I know 4 and 12. Can I multiply this by 3? And divide by 3? That gives me 8. But then if I divide by 2 and multiply by 2, now, another way I can figure out if 48 was divisible by 3, 4 plus 8 is 12, and that's divisible by 3, so 48 is divisible by 3. This is your answer.